Let's look at elementary matrices in the context of applying multiple elementary row operations. Because often, if we're applying an elementary row operations, we're not just applying one, right? So if I take some matrix A, and let's say that I want to get this matrix into reduced row echelon form. I want to transform it into reduced row echelon form. Then generally I have to apply multiple elementary row operations, right? So let's do row operation 1, whatever that is. And that gets me to a new matrix, a transformed matrix A1. And then maybe I have to apply another row operation. And that gets me to a different matrix, A sub 2. And I keep on going. I keep on going until I get to my very last row operation. Let's call it row operation K. And that gets me to say my transform matrix A sub K, which might be equal to the reduced row echelon form of matrix A. Okay? So this is how we normally find the reduced row echelon form of a matrix. We apply these elementary row operations. But let's think about this in terms of elementary matrices now. Okay? Each elementary row operation is equivalent to left multiplying by an elementary matrix. So maybe this elementary row operation is equivalent to left multiplying by matrix E sub 1, an elementary matrix. Okay, an elementary row operation 2 is equivalent to left multiplying by matrix E sub 2, and so on. Okay, then at each step, to get A sub 1, I multiply my original matrix A by elementary matrix E sub 1. So this is going to be equal to E1A. And then to get to matrix A sub 2, that's equivalent to left multiplying the matrix before, matrix A1, by elementary row operation E sub 2. Okay, but so E2A1. All right, but A1 itself is equal to an elementary row operation times matrix A. So I could write E2, E1, A. You see that? And I can keep on going until I get matrix AK here. So my last matrix is furthest left, my last elementary matrix that I apply is furthest left. So in the product, it actually goes first, right? And then I multiply all my elementary matrices in turn. And then finally, my original matrix A. So I could string together these elementary matrices to get any matrix that I can get through elementary row operations, including, most importantly, the reduced row echelon form of a matrix. It's just the product of the original matrix with elementary matrices. Okay, I want to emphasize one more time, though, the order of the matrices. Okay, the very first elementary row operation we apply is the elementary matrix furthest right. The very last elementary row operation we apply corresponds to the matrix furthest left.